Part 3, Force and Pressure. In this video, we will discuss about pressure exerted by liquids and gases, and atmospheric pressure. First, we can discuss about pressure. Let us perform with an activity. Take 5 wooden boxes of almost the same size. Fill them with scrap iron to make them heavy. Arrange these boxes on a wooden table, placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, weight of boxes upon it. Now, rearrange these boxes on the same table, placing them towards the center, one over the other. Now, see the impact in this arrangement. The table either bends or breaks under the weight of boxes. Can you guess why does this happen? Though the force applied in both the cases is same. But in the first case, impact is less, and in the second, the table bends. This activity proves that both the force and its coverage area are important. Smaller the area on which the force acts, greater is the impact, and this phenomenon is known as pressure. We can also say that pressure is related to the force. So, we can say that the force acting on a unit area of a surface is called pressure on which it acts. The SI unit of pressure is Newton per meter square or Pascal. Daily life examples of pressure. Have you ever noticed that why school bags have wide straps? Why sharp knife cuts better as compared to blunt knife? And why the tip of the needle is sharp? In our everyday life, we all experienced the impact of pressure. A school bag has wide straps so that the weight of the bag may fall over a large area of the shoulders of the child, thus resulting in less pressure. It is quite comfortable to carry the heavy school bag. A sharp knife has a very thin edge. It cuts objects better because the area of contact is very small. The force on the hand falls over a very small area of the object, producing a large amount of pressure, and thus large amount of pressure cuts the object easily. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. Do liquids and gases also exert pressure like solids? Do you know what happens when you blow air into a balloon? It exerts pressure in all directions. That's why the balloon increases in size and shows equal enlargement in all directions. The same is also true for liquids. It also exerts equal pressure in all directions. When a plastic disc submerged in water, it does not fall down. It is continuously pressed against the glass pipe by the pressure of water. This implies that the water exerts pressure in all directions. Air and our atmosphere. We know that there is air all around us. This envelope of air around the earth is known as atmosphere. Actually, air has weight and therefore exerts pressure. The pressure of the air upon the surface of the earth is called atmospheric pressure. Note that the atmospheric pressure is decreasing as we go up and up. On an average, the weight of the air in our head is 1 kilogram per centimeter square. Daily life experience of atmospheric pressure. In our day-to-day activities, we experience various instances of atmospheric pressure. Some common examples are sipping cold drinks through a straw, dipping the nozzle of the syringe in the liquid, filling of ink in fountain pens. Do you know what happens when you sip the cold drink? The air pressure inside the straw is reduced and the air pressure on the surface of the drink pushes the drink up into the straw to reach our mouth. In case of a syringe, the doctor dips its nozzle into the liquid and pulls the piston, thereby lowering the air pressure inside the syringe. In another example of ink-filled fountain pens that have rubber tubing, the rubber tube is pressed to push out the air from it, thus reducing air pressure inside the tube. Summary of this chapter, Force and Pressure. Let us summarize what we have learned. Force is a push or pull resulting in motion of a body. Force can change the shape of an object, move an object from the position of rest, change the direction of a body in motion and change the speed of the moving object. There are two kinds of force: contact force and non contact force. Muscular force and force of friction are the examples of contact forces. Gravitational force, electrostatic force, and magnetic force are the examples of non contact forces. Force per unit area is known as pressure. Pressure from solids is due to their weight and acts downward, but in case of liquids and gases, the pressure exerted by them is downward, sidewise, and upward also. That means in all directions. The envelope of air around the earth is known as atmosphere. The pressure of the air upon the surface of the earth is called atmospheric pressure.